Now we have learned that for a stable nucleus, its actual mass is less than the total mass of its constituents. Okay, so what has happened to this mass? So when the free nucleus, that is the neutrons and protons, protons come close together and combine together to form a nucleus, then some of the mass, a fraction of the mass of the constituent, the nucleons disappear, and the disappeared mass is released as equivalent energy according to Einstein's mass energy equivalence relation. Okay, so when the free nucleons, that is neutrons and protons, come together to form the nucleus, some of the mass will be lost, and that amount of lost mass will be converted into energy. So that energy is called binding energy of the nucleus. Conversely, what we can say that, so as the nucleus is about to form, the nucleus are coming close together and they are forming, some amount of energy is released. Okay, some amount of mass is lost, and that much mass is converted into energy, or some amount of energy is released or evolved. Conversely, what we can say, in this way a stable nucleus is formed. Conversely, what we can say that if we have to break up that stable nucleus into its constituent particles, okay, if we have to separate each constituent particles, that is the protons and neutrons, okay, then we have to supply some energy to that particle. So what happens? So when we are supplying energy from outside, the neutrons and protons become excited so that they cannot stay inside the nucleus, and they move away from each other, or they come out of the nucleus and the nucleus is broken up. Okay, so that energy is also binding energy. Okay, so we can define binding energy in two ways. First one is that when the nucleons come together to form a stable nucleus, some amount of mass is lost, and that amount of mass is converted into energy, which is called binding energy. Now to break up the stable nucleus, we have to supply same amount of energy to the nucleus so that the neutrons and protons are completely separated. Okay, that is also the binding energy. Same amount of energy needs to be supplied to the nucleus. So if the disappeared amount of mass is delta m, that is the mass defect, okay, then the binding energy will be delta m into c square. So again you see here we are using the mass energy equivalence of the Einstein. Binding energy EB is delta m into c square. Now where delta m, we know the total mass of the nucleus minus mass of the actual or measured mass of the nucleus after the formation of the nucleus. So total mass of the nucleus is, if there are Z protons and N neutrons, then total mass is Zmp plus Nmn minus actual mass, which is M nucleus. Now generally if EB is greater than 0, that is positive. EB positive or binding energy positive means when during the formation of a nucleus, if energy is released, then the nucleus is stable, that is total mass of the constituent nucleus is greater than the actual mass of the nucleus. Some amount of mass is lost, that much is converted into energy called binding energy, and that is positive. So then the nucleus is stable, and we have to supply energy to break up the stable nucleus. We have to supply energy from outside. Okay. Okay, but if the binding energy is negative, then the nucleus is unstable and will disintegrate itself. Binding energy negative means we don't have to supply energy from outside to break it down, but instead it itself will break itself into its constituent particles, okay, until it becomes a stable nucleus, like it happens in case of radioactive nuclei.